Salish Sea, and the Salish Sea is the waters that include the Puget Sound and the surrounding areas to the north. The killer whales are a very interesting whale because they are what we call resident whales. They are fish-eating whales. So these whales eat pretty much salmon, and they eat pretty much king salmon. You can see here the area where the whales are found during our study period by the circle here. And this area here, in this portion of the map, is the San Juan Islands, and you can see Vancouver Island in Canada. And the whales will typically come in through this strait here and move all the way up into this part of the Salish Sea. And they're coming here to feed on Chinook salmon, which are the largest and the fattiest of all the salmon that occur. The Chinook are also known as king, and that's because they are so large. So these salmon move up this river here to spawn, and they are arriving as full adults and very, very rich in nutrients. These salmon tend to peak in their spawning time around the middle of August, and so the whales are coming in here around May or June, and they're kind of assessing how much food is there and deciding whether or not to stay here and forage or not, or go out into the sound until the fish really start to increase. Now, one of the things that is really interesting about these whales, though, is that, so this is that same area that I was showing you. This is just a different map here. Now, in the blue, oddly, is in this map is land. So here's the water in white. And during much of the year, these whales are out in the open ocean. They're along the Pacific Ocean, moving. Some of them are moving very far south along the Washington coast down to Oregon as far as California. Others are moving up towards the west side of Vancouver Island in the wintertime. And during the winter, it's very, very harsh. It's cold for the whales. They are spending a lot of energy thermoregulating, controlling their body temperature. And it's very different situation for them then, because these whales are essentially feeding on a wide variety of fish compared to what they're feeding on during the summertime. In the summertime, they're eating the big adult fish primarily that are getting ready to move up the river, that are all well concentrated along the, concentrating towards the mouth of the river. But in the wintertime, they're out in the open ocean using a lot more energy, and they're really feeding on several species of fish. We're not really sure how many, but we certainly know that they're feeding on all different age classes and sizes of fish. So it's harder for them to find food. They're spending a lot of energy keeping warm. And then when the spring comes, they need to find a good source of food to replenish their energy reserves. And what we find is that around April, they're right along here along the mouth of the Columbia River, and they're feeding on these early spring Chinook salmon that are starting to move up this river to spawn. Now, these Chinook, these early spring Chinook salmon moving up the Columbia River, are very unique because they travel an extremely long distance to spawn, the fish do. And once the fish enter this river mouth, they stop eating. Because they have such a long time to travel, they arrive as some of the fattiest of the Chinook salmon that are available in the world. And so this is an extremely important food resource for these whales, because it essentially replenishes them from the harsh winter when they have been expending all this energy, and it allows them to sustain themselves until they move up here into the San Juan Island area, where, remember, they're feeding on the salmon that are going to go up this Fraser River, but those salmon don't peak until August. So they're here in April feeding, and they're replenishing themselves from the summer, and they're getting enough reserves to hold them until these fish up here are ready to spawn several months later. And you can see that over in this diagram here. These red dots, or red arrows, are essentially showing you a whale that has a tag on it so that you could track where it's going at what time of the year. And this is around April, where we find that the whales are essentially sitting at the mouth of this Columbia River foraging on these important fish for them. So it's important to understand the whole cycle that these whales are going through to understand the challenges that they are facing, because it's not just the fish over here up into the Fraser River that's important for them in the fall, but it's also these fish down here in the Columbia River that are extremely important too in the spring. And if they need both of these fish runs as well as other fish runs in between to sustain them. This kind of shows you how the two different fish runs work together, or essentially how they complement each other. So remember, we were talking about the Columbia River fish, which is in the gold at the mouth of Columbia, and then the Fraser River when they're in the summertime. And you can see, so here, this is showing you the abundance of the fish over time. This is, we call this term Julian Day, which is really the day of the year. So this is the 100th day of the year. So that would be sometime in April. And this would be the 300th day of the year, so that would be nearing the end of October. And you can just see here that the Columbia River fish, will rise and fall, and then the Fraser River run starts to increase and take over. And this is not a bad year, because the Columbia River fish are reasonably abundant, and then the Fraser River start to rise soon thereafter and increase. But there are certain years where it's not so good. Like if you look at this year here, the Columbia River run is very, very low, and the Fraser River run doesn't start to increase until really far away. So this is a tough year for them, because they come out from the harsh winter. They don't get much replenishment here to rejuvenate themselves from the harsh winter, and they have, as a result, very little to sustain them until this fish run in the Fraser River starts to increase. Now, it used to be the case that in between this run and this run, there were many other Chinook runs that they could feed on, but many of them have been overfished to extinction. So it means that the relationship between the Columbia River run and the Fraser River run is now much, much more important than it ever was historically, because most of the fish in between those runs are simply not available to them. One of the things that's really important about populations, the killer whale is an endangered population. So it means that this population of whales, the southern resident population, it is endangered. But in the case of the killer whales, they're abundant in many other places. So it's really this population of whales that we're saying is endangered. And that's very different from saying like the grizzly bear is an endangered species, or the elephant is an endangered species, where it's endangered every place that it lives. In this case, it's this specific population of whales that are eating only these Chinook salmon that are endangered. And we've been trying to figure out why, and why is it that these whales are unable to recover. One of the things that's happening is they're simply not making any babies. And you can see that here. So this graph right here, the colors are showing you the different pods. This is J pod, this is K pod, and this is L pod. These are the three pods that make up the southern resident population. And this is telling you the total number of adult females of reproductive age, females that are 10 or more years of age, up to 42 years of age. And you can see here that in total, there's about 30 of them in the population between the three pods combined. Okay, and you can see that from 2007 all the way to 2016, the present, they're pretty much around 30 adult females. give or take a couple. Now, these whales typically, a healthy whale would give birth and nurse that that baby for several years, and then wouldn't have another birth for about 5 years. So for that reason, we expect these 30 whales to, on average, produce about 6 animals, 6 babies each year, because some of them are they're all at different stages of pregnancy or of nursing their calves and getting ready to conceive. So on average, about 6 females should be ready to reproduce every year. The rest are at different stages of reproduction. But this is showing you the number of births that those 30 females actually have, again by pod. And you can see here that, for example, K-pod had no births this year. And there was a total of only 4 births in that year compared to the expectation of 6. Now this year, there was only 2 births. And K-pod did have some, and the other L-pod had some, J-pod had none. But as you start moving more towards later years, we're seeing very few births. I mean, here they had 3, here they had 2, here they had none. This was that year, remember, that I described to you where the fish runs looked really poor. Remember, the Columbia River had very few fish, and it took a long time for the Fraser River fish to increase, and they didn't increase very much. No births happened that year, and the next year only 2 births. We had a birth peak here in 2015, but then in 2016 it was bad again. So this is showing you in total that part of the problem with this population recovering from its endangered status is that they're not making enough babies. Now the question is, are they getting pregnant and losing those pregnancies, or are they simply not getting pregnant at all? And can we show the reason for this reproductive problem that they're facing? Now, there are a number of pressures that have been described to impact these killer whales. They were listed as an endangered population in the United States in 2005. And at that time, it was believed that there were 3 pressures that were impacting them. One is the availability of prey. Now, I've talked quite a bit about that. I mentioned that they only eat Chinook salmon. I mentioned that the Chinook salmon are the largest and the fattiest of the salmon. And one really interesting thing about these whales is that, at least during the time when they're studied from May through October, they really seem unwilling or unable to shift to another kind of salmon. For example, you might have heard of another common salmon called sockeye. Well, sockeye salmon have a very, very abundant run that occurs right in the same study area. And even though these whales are running out of food, they still don't eat the sockeye. They just eat the Chinook. And one of the problems about that is because the Chinook has been so available to them throughout much of their evolutionary history and such a rich source of food, they've essentially evolved to specialize on this Chinook salmon. And for whatever reason, be it a behavioral reason or a genetic reason, they just cannot switch. Now, because these Chinook are so big and wonderful fatty fish, it's also the fish that others like most. So, for example, it's the most heavily fished species by people. And that is partly what's caused the problem. The Chinook is now many of these Chinook runs are now endangered, and that's because they've been overfished by people, and because the habitat for these Chinook has been impacted by people, so the spawning areas have been impacted. The movement of fish through areas, for example, through dams, have created barriers for these young salmon to move back out into the ocean, as well as for the adults to move in to spawn, so you reduce the number of reproduction, the amount of reproduction that's occurring, and their survivorship along the way, and then they're overfished, and now there's lots of seals and sea lions around that are also eating the young salmon. So it's created quite a problem for these whales, and so this is one potential problem for them, is they don't have enough food. Now, another problem is toxins. There are a number of toxins that are in the water all over the world, but some places have more toxins than others. There are three very common toxins in the habitat of the whales, of the killer whales, that may be impacting them. One is called PCBs. Now, PCB is a toxin that it comes from a number of different sources. It comes from electrical transistors that are used to help move electricity, to put electricity into your home, and PCBs are an important chemical used to make those transistors, and sometimes they throw the scrap transistors away and they may bury them or put them in places they shouldn't, and the toxins leach out of them into the water. There are also places along deep in the Puget Sound where a lot of boat building has occurred and a lot of PCBs have been used there. Anything that needs to be flexible has PCB in it. So, for example, in industrial-sized buildings, the caulking along the windows that essentially keep the rain out, those often are laden with PCBs. A lot of times the wires that you use commonly, the copper wires, and they have a rubber coating on them, that flexible material on the outside is PCBs. So there's a lot of sources of these PCBs, and people didn't realize how toxic they were, and they didn't realize that they can come off of these materials and essentially get into the water table when they discard these materials. So that's a big problem for these whales, and particularly the killer whales in the late fall, when they come into deep into the Puget Sound area and the more industrial areas, they get exposed to these PCBs. Another very common toxin is called PBDE. I'm giving you the short name of these toxins, and it's the way you most commonly hear of them. Now, PBDE is a flame retardant, and for a long time, this was put in just about everything that we use in your furniture, in your pajamas, in your children's pajamas, in your parents, in your brothers and sisters' pajamas, and essentially anything that you don't want to burn up, they put this flame retardant in it. And again, they didn't realize the toxicity of this material, and they didn't realize that when people dump these materials, when they're done with them, how quickly they can get into the water table. So PBDE is another very common toxin that these whales are faced with. And then the third one, which I'm sure many of you have heard of before, which is DDT. Now, DDT is a pesticide, and that pesticide was used for many, many years, and it was actually banned in 1973, and one of the reasons that it was banned was because people realized that bald eagles and other birds of prey were being impacted as they eat animals that had DDT in them. The DDT would go into the water, would get into the fish, they were eating the fish, and that was causing the shells of the bald eagle's eggs to thin, and so they were having very poor reproduction because of DDT. But interestingly, that toxin was no longer legal to use starting in 1973. So that's a long time ago. That's over 40 years ago, but we are still having a problem that we see DDT in the food chain. So this is part of the reason why all of these toxins are called POPs, which stands for persistent organic pollutants. They are toxins that stay in the system for a long time. They don't really degrade, so once they're there, they can accumulate into the system. And these toxins in particular are stored in fat. Fats are also called lipids. And so these toxins are called lipophilic, which means they're lipid loving. And over time, these killer whales are essentially, over the years, they're eating fish that have these toxins in them. And what happens is that first, the toxins have now all, if you try to measure the toxins directly in the water, you don't find many of those toxins actually floating in the water these days. They're down into the soil and essentially the earth underneath the water table. And what happens is first there are small fish like herring that are very fatty fish that are spawning in these areas where these toxins are present. And because of that, they're getting that from the water table because they're eating food off of the surface of the ground underwater, and they're accumulating those in their body. And then the Chinook salmon comes, which is also a very fatty fish, and it eats this fat-rich herring, and every herring that it's eating has toxins in it. And so because the Chinook is eating many herring, they're bioaccumulating a lot more toxins than an individual herring has because they're eating lots of herring, each of which has many toxins in it. So as you start to go up the food chain, now the killer whale comes and it eats the Chinook, which has already bioaccumulated toxins from the herring. And so that every Chinook that the killer whale eats has a lot of toxins in it, but now the killer whale are eating lots of Chinook with lots of toxins. So you can see as you move up the food chain, those toxins tend to bioaccumulate. So this is another potential problem for these whales. And it's hard to know, is it fish or is it these toxins? Or maybe there's some relationship between the two, because if the toxins are all stored in the fat, and the fish is what you eat to get the fat on your body, when you start to run out of fish and have to use your energy reserves and burn fat, it may be that you actually dump more toxins into your body and cause a problem. So it may be some combination of the two. Well, the third pressure facing these whales is boats. Now, there are two kinds of boats that are impacting them. There are kind of these small vessels like you see here, which would include whale watching boats, which range from small size like you see here to much larger size that may have 100 or more people on them. There are fishing boats also that are small vessels, and just other private boats that people are using. And then there are also the big tankers. We're not going to talk about those today, the big tankers, but we're talking mainly about these small boats, because one of the things that's happened is everybody wants to see the whales. And so the amount of boats around these whales during the nice times of the year when it's pleasant to be out on the water can be enormous. There can be as many as 100 boats. This is an extreme case, but not unheard of. 100 of these whale watch boats around 10 whales. And what happens is they don't just come see the whales and then leave, because there are many different boats around them. And what happens is this boat here is there watching the whale, and it's far too close in this picture. And it's there for a while, and now it's going to go. But before it leaves, another whale watch boat comes up, and it sees that these guys are here, and it goes, oh, there are the whales. So it comes up and it takes its place, and this one goes. And this is happening all day long, so that by about 9 in the morning, these whales already have many different boats around them. And it doesn't stop until it gets dark. And so they really can't free themselves up from them, and it may cause them stress because they want to get out of their way. But it also may impact their ability to find fish, because these whales find fish by echolocating. They send out sound, and the sound hits the fish and bounces back, and that allows the whale to tell how far away this fish is. But all of these boats are making noise, and they're in their way. They're disrupting the sound pattern. So essentially, it's impacting their ability to find these fish potentially. So you can see how big of a challenge it is. Is it all three of these pressures? Is one more important than the other? Which ones do we try to regulate to help these salmon? Well, one of the things that's happened is that the boats are the most conspicuous problem. You know, if you're out there watching the whales and you really love the whales, it actually gets quite annoying to see how many boats are around these whales all the time, and people get really annoyed by that. So this is probably the most regulated of the three pressures facing these whales, but it may not be the most important. It may just be that it's the most conspicuous. So how do you figure all this out? Well, believe it or not, the way we do that is we use feces from the whales. You can see in the background, this is a whale breaching, and right there, it's pooping. So essentially, this is going to be a blob on the water floating, and we have a unique way that you'll see in a minute of finding the poop floating on the water. But what I want you to know right now is what's in the poop and why do we care. And there's a tremendous amount of biological material in feces because this is the way that the body gets rid of things from its body that it's no longer using. Not only is that digested food and what's left of it, which goes out, but it's also your genetic material in your body. When cells die, they're sloughed off in the feces, and so we can get the DNA from the animal in its feces, and from that we can tell what species it came from. So if we're collecting poop on the water, we need to make sure it really came from a whale. Well, we can tell that from the DNA in the whale. We can also tell the sex of the animal from the DNA in the whale. We can even tell the animal's individual identity. Who is that? Because it's got a unique genetic signature that we can identify from the DNA that we get out from the poop. And actually, you can even tell what fish it ate, what different strains of salmon did it eat, because that salmon also comes out in the poop in its DNA. And all of that information we can derive from the feces of the animal. We also get a variety of hormones from the animal. And as you know, hormones are kind of, they're kind of directions to the body and essentially allowing it to do all kinds of different things. It may be a way that the animal responds to stress. It may release a hormone called cortisol when it's under stress, and that can be stress from boats or it can be stress from not enough food. And what cortisol does is it essentially causes the body to metabolize or to release the sugar in the body, which is known as glucose. I'm sure you've all heard of glucose. So when you're under a stress, like a predator's coming or something else is coming that you really need to get out of there fast, or you're running out of food and you need energy to find food, you need glucose to do that. So the hormone cortisol is essentially mobilizes glucose so that you can do that. Another hormone that we measure is for reproduction, that is important for pregnancy. So when animals are pregnant, that hormone called progesterone increases in the body, and etc. So we can look at all of these different things by the hormones in the body, and then we can also see things like endocrine is another word for hormones. Endocrine disruption is when that hormone pattern gets disrupted, and that disruption often is caused by toxins, which we can also measure in the feces. So we can measure all those toxins I was talking about, PCB, PBDE, this is a metabolite of DDT, and this is PAH, which is another toxin in the water that I didn't mention. This is a toxin that comes from oil. And essentially, if there was ever an oil spill, you would see loads of PAHs accumulating. We can measure all of these in the same poop sample. We can also measure pathogens in there, and we can even measure markers that tell us about the health of the immune system and whether it's being suppressed or activated. So the feces actually provides us a tool, not unlike blood tells a doctor how healthy you are when you go in there for a health exam. The doctor will take a blood sample and they'll not just measure one thing, they'll measure all kinds of different things to get a picture of how healthy you are. Well, feces does the same thing for us, only it's a lot easier to get feces from the whale than it is to get blood. But the reason that it's easy to get the feces is because of... Oh, my slides aren't advancing. Well, that's too bad. Okay, well, I'm not sure how to continue here. Just give me a moment so I can... Okay, well, I guess I'm going to continue this talk without the slides because unless there's someone that can help and figure out what's going on here.
Wait, Sam?
Yes, I do.
Sam, it's Deb. Do you hear me?
Yes.
Sam. Okay, so I think I might be able to advance the slides for you. We seem to be seeing the slides advance. So when you're ready for the slide to advance, I can do that for you. So you can see them better. Do you see the pencil at the top? There's a pencil and an X. If you click on that little format there, you'll be able to see the upcoming slides, and then you can
This right here?
tell me which slide you'd like me on. Yeah, it's like a 3 squares and a rectangle.
Okay, I got you now. Okay, perfect.
All right. Which slide would you like to be
hang
on?
Oh boy, this thing is a little touchy. Okay, so it should be on this slide. Oh,
I'm sorry, I
it's
can't see your
it's
screen.
slide number 9.
Do you know what number?
Of Tucker.
There we go. All right.
Okay, I'm terribly sorry about that. I'm not quite sure what happened. So as I said, we got...
I don't think it's you.
As I was saying, we get a lot of the material from the feces or the poop of the killer whale, but we needed a tool to be able to find these samples. And many years ago, our laboratory developed essentially developed a very highly specialized tool using detection dogs to find fecal samples of all kinds of endangered species all over the world. And most of this work is done on animals on land. We call them terrestrial animals instead of marine animals. And those are really a much simpler job for the dog to do because a dog has a tremendous sense of smell. And essentially, we get dogs for our program and we train them to find this smell and essentially to find the fecal samples of just what we're looking for and to take us to them and show us. It's very much the same kind of system that police use with drug dogs to find drugs, or if any of you have been on international flights and you come off the flight and you see often it's a little beagle in the airport and it's smelling your luggage to see if you brought any food products or other things into the airport from across international borders. Well, we train dogs to essentially find feces of endangered species, and they are extremely good at it. This you see here, the dog that you see here is Tucker. And Tucker can smell killer whale feces floating on the water over a mile away. He smells the samples. Now, one really interesting fact about these dogs in our program is all of them are rescued from the dog pound. So these are dogs that are extremely energetic and they love a ball more than anything else in the world. In fact, we could take a ball and we could throw it next to a steak, and any of the dogs in our program will actually go after the steak. I'm sorry. And any dog in the program will actually go after the ball as opposed to the steak. They are so motivated for their ball. And these are the dogs that we look for in the pound. And the reason we find them in the pound is because people can't handle these dogs as pets. They are so focused on getting their ball. If you had a ball and you just kind of threw it in your living room, that dog would knock down everything in the living room to get the ball. And then it will just pester you if you take the ball away. It won't stop trying to encourage you to give you the ball because there's nothing it wants more. Now, what's really wonderful about those kinds of dogs is even though they may be hard for your average person to keep as a pet and to control, once the dog knows that you have the ball, because it wants it so badly, it'll do anything you ask so it can get its ball. So all of a sudden these dogs become extremely obedient because it's all about their ball. As soon as you throw the ball, you've lost them. They're off to get the ball, but then they bring it back to you because they want you to throw it again. So you kind of have this little rope on the dog that allows it to move out and come back. But what we do is we train the dog that when it finds the substance you're looking for, it might be a drug, or in our case, it's the feces of only killer whales, that we train it that when you find that substance, find that material, in this case the killer whale poop, you get the ball. So they will do anything they can to try to locate the feces of the whale once they smell it. Now, if you imagine if you have a dog on land and it's looking for killer whale feces, now it's kind of easy. You're traveling through the wilderness and all of a sudden the dog gets the scent from the killer whale, from the bear feces, because the wind is blowing over over the bear poop, and it's blowing it towards the dog. So the dog starts moving towards that sample, and when it finds it, we train it to sit. Now, in the water, on a boat, it's very different. You can see that Tucker is riding on the bow of the boat. He can't walk to the killer whale's poop in the water. He has to tell his handler, who you see behind him, where that sample is. Now, the way that we do this is so we are out in the water and we're essentially looking for, we're out there and the whales are in view of us, and we know which direction the wind is blowing, and we know where the direction the whales are swimming, and we also know the direction the current is moving, because once the poop is in the water, the current is going to be moving in a particular direction. So we have to keep all of those things in mind. And so as the whales swim, we imagine, okay, if that whale pooped, the wind is blowing in a particular direction, and then we approach we imagine if the whale pooped and the wind was blowing that scent in a certain direction, we imagine what direction that would be, and we approach it perpendicular to the wind current. Now, Tucker may be just laying on the bow of the boat. He may even be asleep, but you can see his nostrils kind of moving up and down like he's paying attention. And the scent is coming off of the poop in a cone. Scent is coming off of the poop in a cone. If the wind is blowing strong, that cone is very narrow, but it travels very far. If the wind is blowing soft, the cone is very wide, and it doesn't go very far. And as soon as we reach the edge of that cone, one side of the cone, if you imagine like a triangle, one angle of the triangle, and Tucker gets that scent, now he realizes, oh my gosh, I can get my ball. So all of a sudden he is up and excited as can be, and he's leaning well over the bow of the boat like you see here. Now, as the boat continues to move towards the center of the cone, which is where the scent is strongest, eventually the scent is no longer going to be in the front of the boat. It's going to start to move to the side as you start to get away from the strongest part of the scent. It's no longer in the front of the boat. Now it's moving along the side, and then Tucker will turn to the side of the boat, and that tells the handler to tell the driver of the boat to move quickly in the direction where Tucker is leaning over the side of the boat. And then once you get back into the scent cone, now you're moving directly to it, which is what you're seeing in this picture now. So now the dog handler is essentially watching Tucker's movements relative to the wind, and she's making very, very slight adjustments until we get until we get all the way up to the sample. And when we get into the actual sample and it's right there, now the scent is swirling all around the boat, and Tucker can't locate it anymore. So he starts to whine, and in fact backs off the bow of the boat, and he's whining. And so we know that it's right there. And everybody's looking over the bow of the boat or the side of the boat looking for the sample, and finally someone sees it, and so we start to scoop it out really fast before it sinks. And the first scoop that comes out of the boat is presented for Tucker. He's excited as can be, and as soon as that happens, he gets his ball and he's playing like crazy on the bow of the boat while we're all working like maniacs trying to scoop the poop out of the water before it sinks. Okay, next slide, please. Okay, so now you can see in this slide here the San Juan Islands there, and essentially in green, and you can see a red jagged line, and that's showing you the border between Canada on the left and the U.S. on the right, and all of those pink stars are showing you where Tucker found poop samples in 1 year, in essentially over about a 4-month period on the U.S. side, and the green stars are showing you where Tucker found them on the Canada side. So you can see Tucker gets a lot of poop samples over this period. And remember, we're getting all this information from those poop samples. Okay, next slide. Now, the first thing that we wanted to know is, are these whales getting pregnant? And to do that, we needed to rely on hormones in the feces. In the whales, there are 2 important hormones that we see in the feces that essentially increase when the animals are pregnant. One of those hormones is called progesterone, and you can see that up here, up on the top. And the other hormone is called testosterone, which you can see in the graph on the bottom. Now, this is a hormone profile over time, so showing you over time. And what it is it's accumulation of many samples collected from many different whales. And you can see on the bottom of the graph, the x-axis, is, I can't really read it very well on my computer, but it's essentially showing you from moving backwards from the day that the animal gives birth. That's called parturition. So the day from parturition would be, the day of parturition when the animal gave birth would be 0, and that's a vertical line that you can see on the graph. And then as you move to the left, you're getting farther, you're getting at earlier stages of pregnancy. So imagine starting from the left and moving to the right, you can see how the hormone levels are changing as you approach birth. And you can see that they're low until about day 400 days before the animal gives birth, and then all of a sudden the hormones start to rise. And that tells us that the animal is indeed pregnant. Now, the way that we generated this profile is from animals that were pregnant and gave birth successfully. And when the animal gave birth, we were able to, because these animals are followed every single day by people essentially identifying the individuals, and they look for when they're new babies, and when they're new babies, they identify them based on the unique patterns on the whale, especially the area called the saddle, which is the area around their dorsal fin. And essentially when the animal, when the female gives birth, we can estimate how old is that baby when it was first seen. And then based on that age, we can backtrack, because the whales, to figure out when we collected the poop sample, how many days was it before when we actually first saw the baby, and that tells you what stage of pregnancy the animal was in when we collected that particular poop sample from the whale. And so using all of these cases of known births and essentially going back to all the samples we collected from those animals, from the females that gave birth when they were pregnant, we can plot how the hormone levels change with stage of pregnancy. And you see that here again on the top graph. So those are the pregnancy, the progesterone profiles for females over pregnancy, and again you see that sharp rise around day 400, and it stays up until they give birth, and then you see from the vertical line, on the right of the vertical line, they essentially drop to zero immediately. And the bottom graph is showing you the same pattern for a hormone called testosterone, which is commonly thought to be the important male hormone. Testosterone is kind of what you know, is essentially what caused my beard to grow, and essentially testosterone is what makes males fertile. But it also has important functions in females too, and one of those is to help regulate successful pregnancies. So we can use these samples to tell when animals are pregnant. And if an animal is pregnant but subsequently doesn't give birth, then it has had a miscarriage. So essentially, when we are going along and we are collecting samples, and this graph here is essentially showing you the hormone levels from all the different age sex classes of the whales. And you can see that the hormones with gray bars is the hormone testosterone, and the hormone with black bars is called progesterone. And you can see for each age sex class. And so for testosterone, you can see that there's one animal that the first bar that looks moderately high, if you look under there, that's an adult male. So adult males have high testosterone. But as you move to the right, you see 3 black bars there going up, which is the hormone progesterone. And you also see that testosterone is also high in those animals only. So what we can see is that the pregnant females have high black bars, which means high progesterone, and they also have high gray bars, which is high testosterone. The adult male, though, has only high testosterone. It doesn't have high progesterone. So the combination of high progesterone and testosterone tells us that it's a pregnant animal, and we've already gotten the DNA from the animal, so we know that that's a female. And we can tell that these animals are all pregnant. Now, what we can also tell from this is that, you see that there's a little red arrow going from the figure on the right to the top figure on the left. And I'm sorry I don't have my arrows to show you this, so you just have to notice this. And you can see that for the pregnant animals, that arrow is showing you what we call a threshold of progesterone levels, which means that any progesterone sample above 2,000 represents 2,000 nanograms per gram. It's the concentration in a gram of feces. Anything above 2,000 is a pregnant animal. And you can see from the graph on the right, the only ones that are above 2,000 are those pregnant females. And so on the left shows you that threshold. It's a dashed line there, a dashed horizontal line. And you can see that all of the samples in that top graph are above that threshold pretty much. And that's how we say this animal is indeed pregnant. Now, if you go to the next graph, you can see that there is an arrow from these animals that we're calling. So sorry. If you go, just focusing on this right graph for a minute, you'll see that there are 3 types of pregnant females here. The ones on the far right are the ones that were confirmed pregnant animals. So those have kind of they're the rightmost bars that you see high, relatively high black bars, and gray bars. So that's showing you the amount of progesterone and testosterone in a female that actually ended up giving birth. So it was a healthy pregnancy. And then immediately to the left, you see a really tall bars of progesterone and testosterone. Those are females that we call late spontaneous aborters or late miscarriers. And then moving one more to the right, you see a high progesterone but low testosterone, and we're calling those females who are early miscarriers. And the way that we know that is by the, we see that for all these animals that are in the pregnant stage, we see that for the early, in early stages of pregnancy, the testosterone levels are very low. And so that's what that blue arrow is showing you. It's showing that the testosterone levels in those females that had an early miscarriage were very low when we compare that to what it should be in a normally pregnant female. So we know that those females miscarried very early in their pregnancy. And if you go to the next graph, you can see that now we have a top blue arrow, which is showing you from the bars on the right of the females that aborted late. They have very high testosterone levels, and you can see by comparing that to the curve on the left for a normal pregnant female that those were late aborters. So the point is that we can tell these females were pregnant by the progesterone level being above this threshold. And then from the testosterone level, we can tell where they were in pregnancy when we collected that sample. And then because they no longer, the next time we saw them, they were no longer pregnant, we can tell whether they aborted or not, and if they did, whether it was early or late. Now, if you go to the next slide, you can see how many females are having successful pregnancies versus those that are aborting early or late. And I can't really read my slides, unfortunately, but you can. I can tell you that essentially, if you break down how many pregnancies are successful, the number should be around 40% of them, or 35% are successful births, and then you see a portion that are on the right. Just look at the red percentages on the right most part of that table, and you can see that there's a fairly large number that have early miscarriages or early spontaneous abortion, and a fairly large number that have late miscarriage. So about 65% of all the pregnancies end up miscarrying, and about of all of that total 65%, about 40% of those are late miscarriages. So what that means is that these females are giving birth, are getting pregnant, but they are losing their pregnancies. Okay, so now moving on to the next slide, there's two other hormones that we measure that look at the nutritional health of these animals. One that I talked about already is cortisol, which mobilizes glucose and gives you high energy. So when you are running out of food, that hormone cortisol goes up in the body. It elevates to tell you to make more glucose so you can find food. Another hormone that you see on the right of these graphs is thyroid hormone. Thyroid hormone is another important nutrition hormone. It controls your metabolism. And essentially what it does is when you are running out of food, the brain tells your body to lower the amount of thyroid hormone that is circulating. And what that does is it causes your metabolism to slow down. And the reason that that's so important is if you're running out of food, you don't want to be using all of your remaining energy reserves too quickly, or else you're essentially going to extinguish. You'll die. And so thyroid hormone, when you're under nutritional stress, goes way down to lower your metabolism so that you essentially use your remaining reserves more slowly until you essentially can find enough food. So when you're out of food, the cortisol goes up to give you energy to find food, and the thyroid hormone goes down to kind of put the brakes on. So what that tells you is that we can look at those two hormones together, and we can see when animals are under nutritional stress. And the pattern you expect to see is high cortisol and low thyroid hormone. Now let's go to the next slide. This is showing you essentially the thyroid hormone levels in black and the cortisol levels in gray, yes, and the cortisol levels in gray, and for each of the age sex classes that you described, that I described before. And when you go to the next slide, you can see that there is one group out of all of them that has that poor nutritional pattern that I described of high cortisol in gray and low thyroid hormone in black. Everybody else is the reverse pattern, essentially, or equal amounts of the two. So, and you can see the ones that have that pattern are these late aborting females, the females that lost their pregnancy very, very late at a very late stage of pregnancy when it's very costly for them. And if you go to the next slide, you can compare those females to the ones that gave birth successfully, and you can see that they have a really good nutritional pattern. They have high thyroid hormone, which means that they got plenty of food, and relatively low cortisol, which means that they're doing okay. So when you compare the two, you can see that the ones that aborted or had miscarried late were the ones that had a poor nutritional signal. Now, if you go to the next slide, we also wondered about toxins, and this shows you our ability to measure these toxins in the whale's feces. And it's very important when you're measuring these things that you know that you are measuring them in a manner that is biologically realistic. And to do that, we do many of tests, and I didn't go through these for the other, how we verified that the hormone measures were working and the DNA measures were working. But this is showing you for how we measured, and I didn't show you that we've done lots of those tests, but many, many years ago. More recently, we developed ways to measure these toxins in feces. So we did some more careful validations. The first thing that we did was we took tissue biopsies from 18 different animals, and we measured, this is showing you for PCBs, we measured the different metabolites of PCB in the tissue of these animals. And then for those same 18 animals, we took fecal samples and we developed ways to measure the toxins in the feces as well. And we compared them for those 18 animals for all the different metabolites. And you can see as you go from left to right that for each metabolite, the amount of hormone in the tissue in gray and the amount of hormone in the feces in black are beautifully corresponds, which shows that our measures of the toxins in the feces are quite reliable. Now, if you go to the next slide, we're getting to the end of this talk. And in the next slide, you can see different, the metabolites of PCBs on the left are big PCB molecules, and those are the ones that stay in your fat and are stored in fat for a long time, whereas the ones on the right are smaller and are dumped out really quickly. And so the ones on the left are the ones we are most interested in. And you can see among those, the one that is most highest is that second bar. And that second bar is way higher than all the other, than the PCB levels and all the other bars there. And those are all from adult females at different stages of reproduction, either not reproducing, nursing, lactating, or pregnancy. And essentially, the ones with the high bars are the ones that were pregnant that aborted. So we see a couple of things now. When you put it all together, the ones that abort, we know, have poor nutrition. I showed you that in the earlier graphs. Now, when they are running out of food, they start to burn their fat. And when they burn their fat, which is storing all of these toxins, and the toxins, when they're in fat, they're pretty much locked up and not doing much damage. But when they are running out of food and they start to burn their fat, those toxins go into circulation. And we know they're in circulation because that's also when they poop them out. And so we can tell from the toxins in the feces that two things are going on. These animals are getting pregnant, but they are not keeping them. And they're not keeping them because the ones that are losing them are running out of food. And when they run out of food, they also burn their fat and dump the toxins into their circulation. And that combination is a cumulative effect that caused them to abort. Next slide, please. So to summarize, what we see is that two things are very important here in these whales. They are running out of food. They are not having enough food, but they also have a lot of toxins in their system, which are combining to cause this problem. But the thing that should be pretty clear by now is that if the fish levels stay high, that keeps the toxins that these animals have bioaccumulated all their life locked up in their fat, so it does less damage to them. So if you are a manager trying to figure out, well, what do we fix first? What you most want to fix first is the fish. You want to get fish levels back up to a high level to keep these animals healthy and to reduce the exposure of the body to the toxins at the same time. And that buys you more time to also clean up the toxins in the sound. So I didn't talk much about boats because it turns out that the boats are not nearly as important as are the fish in these animals, and they do disturb the whales considerably, but it all comes down to the fish. And again, if it, to the extent that boats are a problem, if there are a lot of fish, the impact of the boats are going to be less. So that's kind of the story. If you go to the last slide, you can just kind of see essentially my colleagues that have been really important in helping us in this program, and they're all waving at the end of a very successful day when we found lots of poop, and we're all very happy because of it. And you, of course, see Tucker, our wonderful Tucker, looking at you in the background. And that's it. Thank you. Does anyone have any questions?